We come nearly at the end of Mangrove series. One more episode will be published in next week. Today we discuss about methodology for degraded mangroves. To identify degraded mangroves for restoration, some survey and studies are to be undertaken, like floristic and vegetation survey. This survey will help in determining the nature of degraded areas and the species composition. One can use high-resolution satellite images to conduct this study. Another is Participatory Rural Appraisal, PRA. Here, by using transact work, resource mapping, and historical analysis, degraded mangroves area can be identified. Topography survey using theodolite, total station, DGPS instrument, and preparation of contour map for 5 cm level and development of GIS database using computer aided packages, remote sensing and GIS packages will help to map degraded patches of mangrove. Further, hydrodynamic study in the mangrove creeks by deploying self-recording tide gauge, temperature and salinity study with the help of salinity temperature probe over a day in the creeks, hydrological and geomorphological reasons for degradation of mangroves can be gained from the communities through focus group discussion with them. Before going to restoration program, we have to prepare village level microplan and arrange manpower through constitution of village level institutions like Eco Club, Eco Development Committee, Bon Sangrakhan Committee, Bon Sangrakhan Samiti, self-help groups, cooperatives, etc., and have to run skill enhancement program through training in nursery raising and canal excavation, which will require for restoration of degraded mangroves and for the enhancement of their livelihood also. In most of the degraded mangrove area, geomorphology and hydrology study shows that the area lying close to the banks of creeks or river are elevated compared to the areas inside due to deposition of silt during floods. Secondly, the soil subsided in the clear field area due to changes in bulk density, making the topography saucer-shaped. As a result, tide water entering in during the high tides stagnates in the saucer-shaped area. The temperature and the salinity of the stagnant water increases and shoots up to 114 ppt or more during summer. This phenomenon prevents natural regeneration of mangroves and thus enhances the process of degradation. So, before going to restoration, we have to bring down the salinity first. In order to reduce the salinity, fishbone type canals are dug and tide flushing and draining of stagnant water is facilitated. This has resulted in bringing the salinity levels to nearly 60 ppt in summer to freshwater level during the monsoon season. Excavation of main canal at an angle of 45 degree to the natural creek and excavation of side angle with the angle of 30 degree to the main canal. Design of canals for mangrove restoration is like fishbone in order to facilitate easy inflow and outflow of a tidal river. Now the shape of the canals for mangrove restoration. In order to plant the saplings at the mid of the level of the canal, it is required to dig a canal in the trapezoidal shape. This is trapezium shape. The bottom is less in length, in width, and the top is more in width. This ensures the plant receives tidal water, but at the same time they are not submerged. After a buffer period of 3 months, the nursery raised mangrove saplings and planted along the trapezoid shaped canals. At this juncture, we take a look on a case study of Saveru Creek of Rathikalava Reserve Forest in Godavari mangroves. The maximum tidal range was 60 meters during the southwest monsoon. During the pre-monsoon season, the minimal tide range recorded was 10 centimeter to 20 centimeter, with the maximum range being 60 centimeter to 65 centimeter. In the sanctuary area, the maximum tidal range was 50 centimeter during the southwest monsoon and 1.3 meter during the pre-monsoon. Salinity variation in the Saveru Creek, Rathikalava Reserve Forest varies from 6 ppt during the southwest monsoon to 31 ppt during fair weather season. Based on this tidal amplitude, we have to identify the dimension of canals. The dimension of canals were determined based on the contour level and tidal amplitude. Based on the hydrological studies, the depth of canal for restoration was decided to be 65 centimeter with reference to mean sea level, so as to have adequate tidal flushing. As per the contour, the canals are constructed with a maximum depth near the bands B of the creek and the rivers, creek or rivers rather than the inside. From here, we used capital B to denote the area near the bands of the creek or river, and I denoted for the inside of degraded mangroves. The depth of the main canal varied from 45 centimeter inside to 1 meter at the bank, and the side canals from 60 centimeter to 45 centimeter. The top width of main canal was between 3.5 meter at bank and 2 meter inside, and the respective bottom width was between 1 meter and 40 centimeter. The top width of the side canal was 2 meter and the bottom width was 40 centimeter. The distance between two side canal was 12.5 meter. Planting of mangrove sampling was done 2 meter apart along the canal and at about 20 centimeter down the slope during the first year of plantation. In subsequent year, distance between side canals were reduced to 8 meter in order to ensure dense canopy. As the canal was dug closely, the dimension of the side canals was reduced according to 1.25 meter top width and 20 centimeter bottom width and 40 centimeter deep. Now selection of mangrove species. Based on the salinity level of soils, mangrove species mainly Abyssinia marina, Abyssinia officinalis and Exogaria agalocha were selected for planting in the degraded areas. This the selection of mangroves part I have discussed in my previous video. And this was selected because they can tolerate high level of salinity. Now, the desilting of canals and casualty replacement. The bands formed by the deposition of excavated soil during the canal digging will be sealed the canal during the monsoon. That means when the canal was excavated, the soil was down on the bank of the canals, and this is come to the bed of the canal again during the monsoon season. The silted canals have to be desilted before the onset of summer, because during summer the tidal amplitude is generally low. Tidal flushing is very important during the summer because the soil salinity will shoot up due to high temperature and cause damage to the root of the seedlings. Such seedlings will be replanted in the following monsoon season. So, the survival percentage is measured in the initial period for better monitoring. The first year the survival rate will be less. Initially the growth rate was low, and after 2 to 3 years the seedling will grow at rate was faster. And the natural regeneration of the seedlings occurs simultaneously. And after 4 years the planted saplings start bearing fruits, which will regenerate and density of the area will increase. In the first slide of my today's video was the canal that was dug in 1999, and after 4 years, that is in 2003, the dense canopy was shown. So here that this is the area in 1999 that the canal was dug, and in 2003 in the same area we can see the canopy. So this is from the mangrove forest restoration in Andhra Pradesh. This is the manual of A.M.S. Swaminathan Research Foundation, and this manual was published in 2004. So the information what I have extracted from this manual only. So thank you for watching this video.